Throughout history and the advancement of civilization, the discovery, development, and application of metals has driven the way that people live and societies have been organically shaped. Historians use the inherent link of industrial development and the metals discovered and prevalent at that time to describe certain periods of significant social and technological advancements, such as the Stone Age, Bronze Age, and Iron Age.
And different techniques like alloying and heat treatment that can be used to improve their properties. Around 2/3 of the elements in the periodic table are metals, although for engineering purposes, we're particularly interested in just a handful of them. Iron is probably the most important of them all because it's used to create steel, a high-strength material with a wide range of engineering applications. Aluminum is commonly used because its alloys have high strength-to-weight ratios. It has a relatively low melting temperature, which makes it easier to process and use for casting, and it's relatively inexpensive. Like aluminum, titanium has excellent strength-to-weight properties, although it is even stronger, making it a popular choice for aerospace applications. Its high melting point makes it suitable for applications at high temperatures, but makes processing more difficult. It's also much more expensive than aluminum. Other important metals include magnesium, copper, and nickel. The key to using these metals effectively lies in understanding how they're structured at the atomic level.
The metals at the top of the reactivity series are powerful reducing agents since they are easily oxidized. These metals tarnish or corrode very easily. The reducing ability of the metals grows weaker while transversing down the series. All metals that are found above hydrogen in the reactivity series liberate hydrogen gas upon reacting with dilute hydrochloric acid or dilute sulfuric acid. Physical properties of metals. All the metals are good conductors of heat and electricity. Cooking utensils and irons are made up of metals as they are good conductors of heat. Metals are sonorous because they produce a deep or ringing sound when struck with another hard object. Usually, all the metals have a shiny appearance, but these metals can also be polished to have a shiny appearance. Ductility is the ability of the material to be stretched into a wire. This ability allows metals to be drawn into wires and coupled with their durability find applications such as cable wires and for soldering purposes. Because metals can be drawn into wires, we can say that metals are ductile. Malleability is the property of substances which allows them to be beaten into flat sheets. Aluminium sheets are also used in the manufacturing of aircrafts because of their lightweight and strength. Other metal sheets are used in automobile industries for making utensils, etc. Therefore, metals are malleable. Chemical properties of metals. Number 1. Reaction with water. Only highly reactive metals react with water and not all the metals. For example, sodium reacts vigorously with water and oxygen and gets a large amount of heat in the process. This is why sodium is stored in kerosene so that it does not come in contact with moisture or oxygen. Number 2. Reaction with acids. Hydrogen gas is produced when metals react with acids. For example, when zinc reacts with hydrochloric acid, it produces zinc chloride and hydrogen gas. Number 3. Reaction with oxygen. Metal oxides are produced when metals burn in the presence of oxygen. These metal oxides are basic in nature. For example, when a magnesium strip is burned in the presence of oxygen, it forms magnesium oxide, and when magnesium oxide dissolves in water, it forms magnesium hydroxide. What is called metallurgy? Metallurgy is defined as a process that is used for the extraction of metals in their pure form. The compounds of metals mixed with soil, limestone, sand, and rocks are known as minerals. Metals are commercially extracted from minerals at low cost and minimum effort. Principles of metallurgy. The metallurgical process can be classified as the following. Number 1. Crushing and grinding. The first process in metallurgy is crushing of ores into a fine powder in a crusher or ball mill. This process is known as pulverization. Number 2. The concentration of ores. The process of removing impurities from ore is known as a concentration of minerals or ore pressing. In metallurgy, we concentrate the ores mainly by the following methods. Number 3. Hydrolytic method. In this process, we pour the ore over a sloping, vibrating corrugated table with grooves. A jet of water is allowed to flow over the surface. The denser ore particles settle in the grooves and the impurities are washed away by water. Number 4. Magnetic separation. In this case, the crushed ore is placed on a conveyor belt. This belt rotates around two wheels in which one of the wheels is magnetic and therefore the magnetic particles get attracted to the magnetic wheel and fall apart from the non-magnetic particles. Number 5. Froth flotation. In this process, we take the crushed ore in a large tank which contains oil and water. A current of compressed air is passed through it. The ore gets wet by oil and is separated from the impurities in the form of froth. Ore is lighter and so it comes on the surface and impurities are left behind.
Number 6. Roasting and calcination. In metallurgy, the process of heating a concentrated ore in the presence of oxygen is known as roasting. This process is applied in the case of sulfide ores. For ores containing carbonate or hydrated oxides, heating is done in the absence of air to melt the ores, and this process is known as calcination. Solids at room temperatures we occur. A plus high temperatures we boil. I remember a wise man once said, chemistry is full of exceptions. So here enters sodium, potassium and mercury. Soft and liquid they are respectively. Shiny, flashy, malleable and ductile. Yet some can be fragile. Around 95 of 118 elements are metals, and that's very little.